Thank you for inviting to this great university to see the power of Sanskrit. Sanskrit is one of the oldest languages in the world with a rich repertoire of knowledge in the domain of poetry, logic, grammar, philosophy, aesthetics, science, technology, mathematics, and other allied subjects. And contributions in the area of all this which I mentioned has made extensive imprints in the minds of all those who have gone through this and realize the Indian scholars who have made it so popular that it survives even today. Maharshi Panini Sanskrit Evam Vedic Vishwavidyalaya was established precisely for the promotion of the Sanskrit language in 2008 by the government of Madhya Pradesh. Though the motto of the university is to promotion and proliferation of the Sanskrit language and literature, and it is take appropriate measures to promote interdisciplinary studies, innovative research in this university. India surely so it enjoys a place and pride in the cradle of the abiding world of cultures and civilizations. Its ancient literature, mostly rendered in Sanskrit, is extremely rich in its original philosophical thought. It's equally opulent in scientific inquiry. Today, your Honorable Vice Chancellor has just declared Sanskrit as a language for science. To be precise, ancient India as a knowledge society in the area of various aspects, which includes intellectual pursuit in the areas of mathematics, medicine, metaphysics, astronomy, and the Sanskrit Sanskrit literature has been very copious repository of scientific and technological studies since the Vedic times. A notable feature of the scientific temper of these days was integration with the spiritual and the cultural aspect of life. So there were no separation between culture, spiritual studies, as well as scientific studies. So you can see them all merged in one in the poetic language that has been spread through the Sanskrit literature that's available. So it was for a noble cause of the human happiness. So in the modern science world, I think we can understand that all these are created out of those thought processes that existed thousands of years back. If you look through the journey of our Indian culture, you can see that imprints of the contribution of scientists of those times that was expressed in the language of Sanskrit through ages. In any area, astrology, astronomy, mineralogy, atmospheric sciences, biological sciences, medicine, physics, chemical sciences, aeronautical sciences, in which I am connected in some way. So, only point is that though this knowledge has been there, it is not fully exploited to an extent or is not fully researched. And I am very sure that the action that you are taking today to invite people like me to talk about science and Sanskrit will help you to take a next step in showing that this language can easily be used for conveying scientific thought and the process of science in that beautiful language. I think that's the next step that we need to take. Sanskrit's potential as a scientific use was greatly enhanced as a result of the work of Panini, the great work of Panini, and he has created, just out of the 4,000 sutras, virtually the whole structure of the Sanskrit was created, and it which remains stable for next 22,000 years. I think that's what you are studying even today. And this is the structure of the language that gives us such a high value today, that look at from the scientific point of view, that it is created out of logic and structure. Many other languages don't have that capability. I come from a domain of science and technology. I am a rocket scientist. I have been building rockets. So when I look at this journey of language in Sanskrit and the rocket science, the aeronautics that connects them, I'm really fascinated many a times by the work of great scholars and that they have created such great books. The very first book which I have come across in Sanskrit, which talks about the domain which I am familiar with, is the Surya Siddhanta. Many of you would have known about this book. And this is the book specifically talks about the solar system, the sun, the planets, and how the planets move around the sun, the periodicity of this movement, the time scales which are involved, the size of this, the whole structure, even the size of the earth. Even to think that your earth is a sphere, it has a diameter, it has a circumference. I think all these thoughts that happened there that time, it didn't stay here. It traveled all the way through the Arabic travelers. It went to Europe, and thousands of years later, the knowledge came back to us in the form of discovery by the great scientists of the Western world. Though it was all found out here, it was written down in this language, and today we know that it has been created. Varaha Mihira, through his Panchasiddhanta, we know much about it today. Lagadha, in the 1500 year BC, he has created the Vedanga Jyotisha. Aryabhata's work 1, Varaha Mihira's works, Bhaskara 1 and 2. Brahmagupta, it created the Brahmaspuda Siddhanta, again a scientific work. Parameshwara and many others in Kerala, where I am coming from, wrote the Gola Deepika, which is again a very interesting book on astronomy. You know that many of the literature written in terms of the ideas like zero. If you subtract 1 from the 1, you get 0, shunya, the concept of shunya. And equally important is the concept of infinity. I think both of these are the findings of those great rishis, expressed in very beautiful poetic ways. Even you know the algebra, the concept of the mathematical concepts called algebra, the square root of numbers, very precisely expressed. Even Bothayana equated to Pythagoras' theorem. You know, Bothayana was living in during 800 BC. Pythagoras came much later. And he expressed that for a right angle triangle, how the connections between sides are expressed beautifully in the concept of areas. Though he was not talking about square, but he was talking about areas. It's exactly the same theorem of Pythagoras, expressed in beautifully in Sanskrit in 2 sentences. You can read that and understand the beauty of it. Many other concepts, like the concept of Vimana, architecture, the construction technologies, the concept of time, which is beautifully expressed in many, many literature, the structure of the universe and how it evolves and grows bigger and bigger with the time, metallurgy and manufacturing, chemical technologies, medicines, treatment, languages, the structure of the grammar, shastras like Nyaya, law, Sangeet, Tala, spirituality, philosophy, yoga, temple, astrology, and all of this were expressed beautifully in the language of Sanskrit. But the difficulty that is faced by the scientists at that time was this language was expressed more in Shruti and not in written form. And because of this Shruti nature of learning and teaching, the Sanskrit attained a beautiful nature that it is very easy to listen and by heart it, unlike many other languages. And that's why it survived. And today you don't need it. Today you can write it and express it. You don't need that Shruti structure, which is the beauty of this language. It's a rule-based, formula-based, and logical syntax. For people like us who are engineers, scientists, like it very much. Any language which is rule-based, syntax-based is something that suits into computer languages. And you know, computer people who are especially working in the artificial intelligence, machine learning, they like Sanskrit. And there is a lot of research being done how Sanskrit can be used for bringing into computation, natural language processing. And I want to tell you, people who are taking Sanskrit as a profession, as a living, you must look at it how this can now work in the domain of technology. And it is not the old literature and science that we must propagate. It is more importantly how we can use Sanskrit, the language, for conveying the messages of modern technology and science. Then only it will survive. It must become the language of the spoken and the language of the top people who will be able to communicate in this language. I understand the Maharishi Pani University is one of the
Certainly. Let's examine the claims made in the speech and evaluate them based on scientific evidence and historical facts. Claim: the Surya Siddhanta, an ancient Sanskrit text, discusses the solar system, the sun, the planets, and their movements around the sun, providing accurate knowledge on these topics. Evaluation: the Surya Siddhanta is indeed an ancient Sanskrit text that deals with astronomy and timekeeping. However, while it contains some astronomical calculations, it is important to note that its accuracy and scientific validity are questionable. The text includes certain inaccuracies and assumptions that do not align with our current understanding of the solar system. Over time, our knowledge of astronomy has greatly advanced through scientific observations and technological advancements, rendering some of the claims made in the Surya Siddhanta outdated and inaccurate. Claim: Sanskrit texts such as Varamara's Panchasiddhanta, Lagadha's Vedanga Jyotisha, Aryabhata's works, and Brahmagupta's Brahmasputa Siddhanta have contributed significantly to our understanding of astronomy. Evaluation: it is true that these Sanskrit texts have made contributions to the field of astronomy. They contain mathematical calculations, astronomical observations, and theories that were developed during their time. However, it is important to recognize that scientific knowledge is constantly evolving, and our understanding of astronomy has significantly advanced since the time these texts were written. While they provide valuable insights into the historical development of astronomy, they do not represent the current state of the field. Claim: Sanskrit encompasses diverse areas such as Vimana, aircraft, architecture, construction technologies, metallurgy, manufacturing, chemical technologies, medicines, treatment languages, grammar, shastras like Nyaya, Sangita, Tala, spirituality, philosophy, yoga, temples, and astrology. Evaluation: Sanskrit literature does cover a wide range of subjects, including those mentioned. However, it is important to distinguish between mythological or metaphorical descriptions and actual historical evidence. While Sanskrit texts may contain descriptions of vimanas, aircraft, and advanced technologies, such depictions are often allegorical or symbolic rather than literal. It is crucial to approach these claims with a critical mindset and consider the historical and archaeological evidence available. Claim: Sanskrit is rule-based, formulaic, and possesses a logical syntax that resonates with engineers, scientists, and those in the field of technology. Evaluation: Sanskrit does have a well-defined grammatical structure and a logical syntax that has been studied and documented by scholars. However, the claim that it resonates specifically with engineers, scientists, and those in the field of technology is subjective and depends on individual preferences and backgrounds. While the systematic nature of Sanskrit may appeal to some individuals, it does not necessarily imply that it is inherently more suitable for scientific or technological endeavors than other languages. In summary, while Sanskrit has a rich history and contributed to various fields of knowledge, including astronomy, it is important to approach claims made about its scientific contributions with caution. Scientific knowledge has advanced significantly since the time these texts were written, and our understanding of the universe has evolved through empirical observations and rigorous scientific methods. It is crucial to rely on current scientific evidence and critical analysis when evaluating the scientific validity of ancient texts and claims. Claim: The works on astronomy, algebra, Pythagoras' theorem, and Vimana, aircraft, in Sanskrit texts are credible and contain advanced scientific knowledge. Evaluation: While Sanskrit texts do contain references to various scientific and mathematical concepts, it is important to critically evaluate their credibility and scientific validity based on empirical evidence and historical context. Astronomy: Ancient Indian astronomers made significant contributions to the field of astronomy. However, it is crucial to note that scientific knowledge has advanced significantly since the time these texts were written. Modern astronomy relies on extensive observational data, advanced telescopes, and sophisticated mathematical models, which have expanded our understanding of the universe. While ancient Indian astronomers made important observations and calculations, their theories and models may not align with our current scientific understanding. Algebra: Sanskrit texts did include mathematical treatises that covered algebraic concepts. However, it is important to recognize that the development of algebra was not limited to Sanskrit texts or ancient India. Algebra emerged independently in various civilizations, including ancient Mesopotamia, ancient Greece, and the Islamic Golden Age. The principles of algebra, such as solving equations and manipulating variables, were developed and refined over centuries by mathematicians from different cultures. Pythagoras' theorem: The Pythagorean theorem, which states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides, is commonly attributed to Pythagoras, a Greek mathematician. While there are references to similar geometric concepts in ancient Indian texts, it is important to note that the specific formulation of the Pythagorean theorem as we know it today is credited to Pythagoras and his school in ancient Greece. Vimana, aircraft. The concept of vimanas, often described as ancient flying machines, is found in certain Sanskrit texts and epics. However, it is important to approach these descriptions with critical thinking and recognize that such depictions are often allegorical or symbolic rather than literal. There is no scientific or archaeological evidence to support the claim that ancient Indians had advanced aircraft technology comparable to modern airplanes. In summary, while Sanskrit texts contain references to various scientific and mathematical concepts, it is important to evaluate their credibility and scientific validity based on empirical evidence, historical context, and comparison with modern scientific knowledge. Scientific advancements have been made globally throughout history, and attributing the entirety of scientific knowledge to a single culture or language overlooks the contributions and independent discoveries made by different civilizations. Here is a point-by-point examination of the claims made in the speech with evidence-based rebuttals. Age does not equate to accuracy. Many ancient ideas were limited understandings later disproven. No evidence ancient Indians had equivalent knowledge to modern science. Claims of advanced technologies like aeronautics are scientifically untenable and lack archaeological evidence. Astronomy texts contained philosophical models, not scientific theories rigorously tested and validated by evidence. Observations were limited by available technology. Mathematical concepts like zero and place value were independently discovered globally. Origins remain debated among historians. Equating ancient Indian and Greek geometrical theorems lacks historical validity. No archaeological or historically credible evidence to substantiate claims of advanced ancient technologies like Vimana aircraft. Ancient sciences lacked evidence-based understanding of processes, relying on herbal remedies and observations rather than validated causation and cures. Oral traditions degrade accuracy over generations without written records, as shown by comparative studies. Reliance on memorization not preferable for reproducible scientific literature. Logical structure alone does not make a language scientifically useful without associated evidence-based literature, which Sanskrit critically lacks for most claimed fields. More research needed before making extraordinary knowledge claims about any ancient civilization. Facts, not nostalgia, should determine our understanding. In conclusion, while respecting cultural heritage, we must acknowledge factual limitations and avoid inflating dubious claims without credible evidence. A balanced and evidence-based examination is needed before presenting any civilization's scientific achievements. Here are some additional detailed evidence-based rebuttals to the pseudoscientific claims made in the speech. Ancient Indian scholars possessed equivalent knowledge to modern science. There is no credible archaeological or historical evidence that ancient Indians had knowledge of modern fields like aeronautics, spacetime theory, etc. as claimed. Scientific theories are built upon rigorous testing, experimentation, and peer review over time. Ancient sources contained philosophical/mythological models rather than evidence-backed explanations. Sanskrit texts contained advanced sciences like aeronautics. Unverifiable claims about Vimana aircraft or other advanced technologies lack any archaeological, material, or historically credible evidence. Ancient world scientific abilities were limited by available resources/knowledge. Extraordinary claims require extraordinary evidence, which is lacking here. Surya Siddhanta contained modern astronomical understanding. It described a geocentric cosmological model reflecting mythological and numerical symbolism of the time rather than evidence-backed scientific theories. Observational abilities were constrained by technological capabilities. Claims about knowledge of planetary sizes/motions aren't tenable. Ancient Indians discovered mathematical concepts like zero. Numeral system origins including place value and zero remain debated among historians, with evidence suggesting independent discoveries across cultures. Equating theorems like Bodhana's to Pythagoras' theorem lacks credibility without consideration of cultural/historical context and transmission of ideas. Sanskrit conveyed fields like metallurgy/medicine scientifically. Ancient metallurgy and medicine were rudimentary, relying more on practical skills/herbal remedies than validated scientific understanding of processes as seen today. Sanskrit medical texts contain simple observations/prescriptions rather than evidence-backed causation, cure and human biological comprehension. In summary, a balanced critical analysis not influenced by cultural bias is needed to separate extraordinary claims from verifiable facts regarding ancient scientific achievements through credible multidisciplinary research. Mere assertions do not establish the scientific accuracy or equivalency being suggested. Here are some additional points about critically examining claims of ancient science. We must consider technological constraints of the time period. Civilizations were limited in ways to rigorously investigate nature without advanced tools/methods. Reliance on mythology/religion was common to explain natural phenomena before scientific method. But ancient philosophies are not equivalent to modern sciences built on testing hypotheses. Translation ambiguities and difficulties of interpreting ancient texts objectively make verification of precise concepts challenging. Oral traditions fail to convey accurate specialized knowledge across generations without widespread literacy. Written evidence carries more weight. Independent discoveries of similar ideas globally suggest natural human inclination to examine patterns rather than unique ancestral wisdom. Absence of archaeological artifacts supporting claims of highly advanced ancient technologies makes fantastic assertions improbable. Ancient science is often described in broad strokes rather than precise quantification and repeatable experiments required for scientific validity. Lack of peer-reviewed literature demonstrating ancestral transmission of innovations raises doubts about knowledge continuity claims. Extraordinary achievements require extraordinary substantiation through multidisciplinary consensus, not assumptions or arguments from linguistic/nationalistic biases. More transparent discussion acknowledging limitations along with accomplishments better informs understanding versus inflating myths. An objective, evidence-based reckoning of capacities and shortcomings of ancient civilizations respects their contributions while avoiding overstatement beyond credible knowledge. An eclectic integrated historical perspective nurtures progress.
இவனுக்கு எல்லா கலைகளும் தெரியும். உலகின் எல்லா மொழிகளும் தெரியும். He can dance, he can fight, and he is a sportsman. நாட்டு குறிஞ்சி பாடுறேன்னுட்டு உசேரி போயிட்டீங்க. நடுவுல இந்த இடத்துல சதி விலகிடுச்சு.
கோடிக்கணக்கான ஏக்கரை உங்க தாத்தா கவர்மெண்ட் கொடுத்தாரு. பாவ நீ அதெல்லாம் விட்டுட்டு 8 நாளுக்கு 4 நாளுக்கு லாரி தொடச்சிட்டு இருக்கிற. அதான் விதிங்கிறது. தம்பி, ஒரு மனுஷன் போய் பேசலாம், ஆனா ஏக்கர் கணக்கில் எல்லாம் பேசக்கூடாது.